What is it? 5. Oh, very good, Stacy. So then you should be able to tell me the square root of negative 25. Well, then the question is, you say, is it 5? Is 5 times 5 negative 25? Is negative 5 times negative 5 negative 25?
No.
Neither of them are, right? So, what's the conclusion you can draw?
And have a negative recipe.
Okay, close. That's the right idea. What I would say is there's no square root of negative 25, but that needs to be further prefaced, and this is what we're going to learn today. There's no real square root to negative 25, meaning there are no real numbers that are the square root of 25. However, there is a square root of negative 25, excuse me, but it's and negative numbers in general. So if we extended this, what's the square root of negative 9? You'd say, well, there is no square root to negative 9, right? No number times itself equals negative 9, so on and so forth. So what we get from this, the idea we get from this is what I think most people call them imaginary numbers. I don't like that term because I think it's too kid-like. Oh, an imaginary number. I think it presents this idea that it's some fantasy or something like that. I think the better term is complex numbers. A set of complex numbers come from this. So here's the big idea today that we're going to start with. The square root of negative 1. Is I. So anytime you see the lowercase I, like this, that represents the square root of negative 1. I think if you understand that much today, that I is the square root of negative 1, it will make everything we do today really easy. So keep that in mind. Square root of negative 1 is I. So if we go back to the square root of negative 25, then we could say that the square root of 25 times the square root of negative 1 would be equal to negative 25. Everyone agree with that statement? What do we know that the square root of 25 is? 5. What do we know that the square root of negative 1 is? I. So the square root of negative 25 is 5i. Like we said, does it have a square root? Yes, now we can see it does have a square root. It's just not a real square root, it's a complex square root. So, square root of negative 1 is I. Alright, so we're essentially just going to use this idea to help solve some problems we've already been doing, just perhaps some variations of those problems. We need more light. Better? A little bit? Okay. Alright, so let's do this first. Simplify the, let's say, radical negative 90. So, in our process, or what is the process to simplify a radical? What do we need to do with the argument, the number inside the radical first?
Break it down.
Yeah, so we call that the Tree is the process we use. What do we use it for, though? Prime factorization, right? So, how do we factor, or what is the prime factorization of 90? Divide by? I'd start with a different number. 2 is the smallest prime number, isn't it? And we get 45. Then divide by. The next smallest prime number is 3. And again, you could divide by these numbers, I agree, but I think it makes more sense to go in order of from least to greatest. So 90 is 2 times 3 times 3 times 5. And we also need to include in the prime factorization, because it's negative 90. What other factor? Okay, I'm going to say negative 1 first, but I agree. It's going to end up being I. So, first, do we have any pairs? 3s. So the 3s come outside and become A3. What's inside? And we know the negative 1's not going to stay inside, right? So 2 times 5 is 10. And at the end, we need to write I.
Wait, why'd you do negative 1 inside and not I?
Because it's still a square root.
So,
I mean, it's still a square root of negative 1, right? We're just essentially, it's almost like a shorthand for it, right? The I.
so if we give a negative square root, there's always going to be I in it.
Yes. All right, let's try this. Solve negative 6x squared equals 216. What do we do first to both sides? I disagree. Divide both sides by negative 6. Say what you mean. Which I believe is negative 36. Anyone agree? Next step. Take the square root of both sides. So, now we can go back, we can look back up top. What's the square root of negative 36 going to be? And there needs to be one more step here, I think we forget too quickly. I agree, 6i. What should come in front of it? And we probably should have done this with negative 25 anyway.
Radical 36 and radical negative 1.
Nope. In terms of our answer, I don't disagree with you, but we've already moved past that step, right? Anytime you take square root, the result can be or negative, right? So we also need plus or minus with it. So plus or minus 6i. Yes, Connor.
Is there specifically you want to write I? Or doesn't matter?
What do you mean?
Like I after the number, you want to write it like that, or it doesn't matter?
Oh no, yeah, just the lowercase I. Is that what you're asking? Yeah, just the lowercase I. Okay. Adding complex numbers is a lot like adding like terms. And first thing, as you can see, we have the parentheses group the complex numbers here. Complex numbers, this won't be such a big issue today, but it will be in the future, should always come in the form of a plus b I. So make sure you remember that. It will become important in the future. Today it's not as important. It will be important how you give an answer to the question at least. But the real part of the number is always first. The complex part of the number is always second. And again, like we said, we can think of this being just like adding like terms. So, -2 and 14. We add those and get 12. So the real part is 12. Then the complex part, we have I and 4i. What do we get when we add those? Adding them. I plus 4i. Here you go, Cade. You have 2 i's. What if I give you another I? How many i's would you have? 3 i's. So if I have an I and then add 4 i's, how many i's do I have?
Wait.
5 i's.
Oh my gosh. I was just looking at the I. I wasn't looking at the 4 in front of it.
Yeah, so like we said, just like adding like terms, if I have an x and I add 4 x's to it, how many x's do I have? 5 x's, right?
I was just looking at the I, so that's why I thought it would be 4i squared.
And it does need to come, like we said, in this order. Real part, then complex part. Do we need to do another one of those, Cade?
No, I got it.
Are you sure?
No, fine.
Okay.
No, I'm good.
Joan, I don't want to find out that I don't know it. Okay. One more. Completing the square, everybody's favorite. First step of completing the square. Subtract 2 from each side. Move the constant over. So that should give us x squared minus 2x equals 2. -2, I'm sorry. Then do what? Nope. Half the middle term squared to both sides. So half of -2 is -1. -1 squared is +1. This always factors to -1. Good. Half of -2. These add together to -1. Now do what to both sides? Take square root. When we take square root of the left, we get x minus 1. When we take the square root of the right, and remember this, we talked about it earlier, plus or minus. -1. What do you know about that, Cade? It's I. Okay, what do we need to do with this -1 on the left side? Okay, so we should get 1 plus or minus the square root of -1, which we need to change to 1 plus or minus I. So like we said, we're just in the basics today. If you understand the square root of -1 needs to be changed to I believe these ought to be hopefully pretty easy. Any questions?